So in this video, we're going to explore Haskell's some of the type classes that are available in Haskell, and and at least get a very high level understanding of what is the Haskell's type system. So the first thing, let's just put a topic down for today. So what we're trying to do today is you look at the Haskell's. We're going to look at the Haskell's type and some of the types available in Haskell, and more specifically the type classes that are actually some of the standard type classes in Haskell. And after getting a thorough understanding, or at least getting a decent understanding on what all these type classes are, it then at least sets a decent premise in exploring some of the more advanced topics in Haskell, such as what are functors, what are applicative functors, and then getting into the world of monads and monoids, and seeing how I can create my own types that at some point might be instances of these type classes. So, but again, today we're going to look at a kind of a very big high level picture and understanding what basically types are. And so let's start with a really simple example. Let's kind of first thing what I would like to do is create something called a value world. So what I'm going to do is everything in pink over here is basically all possible values. These are just basically a world, a universe of values. I'm going to explain to you in just a second what I really mean there, but I'm just going to segregate two columns over here. The first column is going to be my value world, and the second column is going to be the type world. And the whole idea here is I'm just going to draw a mapping. I'm just going to draw a mapping, or I'm just going to attach a very specific label to every single value that I create. So as an example, to start off, let's have a character. Let's have a character A. If I have a character A, okay, and because it's a character, I'm just going to have these single quotations around my character A. This is some kind of a value, and the value is the character A, but the value has a label. It has a label associated with it which tells it what type that value belongs under. And in this case, the type for character A happens to be a chart, happens to be a just a character. Likewise, if I were to have a string, let's say, I don't know, let's just use my name here, Abbas. If I have a string, this this value this value, you must have already guessed it, that it happens to have a type associated with it, which happens to be a string. In Haskell, this is something called as a list of characters. Okay, it just happens to contain a list of characters. So I'm going to say this is something that happens to be a list. It happens to be a list, but this list is a little bit specific in the sense that it's not a list of integers or a list of numbers. Just happens to be a list of characters. It happens to be a list of characters. All right. Let's just play with a few more examples here. What if I don't know. Let's just have a value. Let's just have a value that happens to be a Boolean value, something such as true. The type that is associated with this value is basically a Boolean value, and the type in Haskell to represent a Boolean value is basically a bool type. Okay. Can I do this with some value that might be tuple? Yes, I can do that. So let's create a tuple over here. And I don't know. Let's just maybe pass in true, and then maybe pass in the string. Let's say a bus. All right. What kind of value? What kind of type is associated with this value? The type that's associated with this value over here is basically, so I just need to be consistent with my colors, is basically a tuple, is a tuple that has as its first component something that happens to be a boolean, and it has as a second component something that happens to be a list of characters. Okay, so so what I have now is I've introduced to you a kind of a notion as to what these some of these simple types are, and from a very high level, these types are nothing but just a label that is associated for every single value. And again, and Haskell basically has a static type system. So all these types are known at compile time. Whenever these values get created, the compiler is already aware of what the type is associated with that value. Okay, these types are not inferred at runtime. These are all available during the compilation. During the compilation stage, it's already known via the compiler. Okay, now this is fine. I mean, these are some of the things you may have already seen in many object-oriented programming languages. But in Haskell, because it's a functional programming, functions are first-class citizens. What that means is, if I were to have a value which is let's create a function here. Let's create an anonymous function. So so I'm going to have a function, and because it's going to be anonymous in nature, let's do this. This is an anonymous function that takes in an x and returns back, let's say, x plus 1. All right. What kind of a value is this? Well, this is basically a function. It's just a function. Does this function have a type? Yes, it does. It does have a type associated with it. And the way I can start off this is saying that this is a function that basically takes in as a parameter something, some kind of a type variable, okay, which I'm going to say in this case with a lowercase a, and it returns back to you something that happens to be some kind of a type that's associated with in this example with a lowercase a, which is in this case a is just acting as a type variable. Okay, now I need to be a little bit specific with my A's here, and we haven't looked at type classes yet, but just because we just haven't looked at type classes yet, let's kind of take a few steps ahead and say that this is a function, this is some kind of function that has the following type, where I pass in a number, and out comes another number. All right, and the best way to understand this is that this piece over here is basically my input to the function, and this piece over here is basically the output from my function. And this arrow over here, this arrow in some sense is giving an indicator that what I'm dealing with here, the value that I'm dealing with in this example happens to be something that is a function. Okay, this happens to be something that is a function, and because I'm dealing with a function, it takes in something as an input and spits out something as an output, and the input and output both in this example happens to be something of a number. All right, and that's my function right there. This is a function, and that's the type associated with that function. Let's take this before we just wrap this up. The very first part of our types and type classes. Let's just play with this a little bit on the Haskell's shell. So so let's do this. I'm just going to let's do this. I just want to make sure we have both the windows available clearly. So so let's do this. Let's first create a string, a character A. Okay, that's my character A there. Okay, and I'm going to ask Haskell. What's the type associated with the character A. And what I get back over here, is basically my. All right, let me just turn on my drawing utility, the pen. Okay, and what I'm just asking Haskell at this point is, what is the type, and how do I know that? Because this is basically, think of this as a kind of a function. It's a function that basically takes in some value, and it gives you back the type that is associated with it. Okay, so whatever happens to be after the after the two colons over here, it tells you that for this value, that's in green, it's the type that is associated with it happens to be in this uh, this character over here. Okay, so in blue, what I see over here in blue is basically the type, and in green, what I see there is basically the value. All right, can I do that with a few more examples here? So let's ask the same thing to Haskell, but now I'm going to pass in a string, and the type that is associated with the string in this case is basically a list of characters. And if I pass in a boolean, I get back a type. In that case, is a bool. And if I create a function, so let's create a function. I'm just going to use a let binding to create a function, but I'm saying a function f that happens to take in some input x and gives back as an output x plus 1. And now I would like to get the type that is associated with my function f. It basically tells me that a in this case, the function f in this case is the type that is associated with it happens to be right here. And again, because we haven't yet looked at type classes, I do not want to get a little bit ahead of myself at this point, but the best way to interpret this is that this is a function because I have an arrow there, and this arrow tells me that I'm dealing with a function, and the input that goes into this function is some type associated with a lowercase a. Just in this case, lowercase a meaning is a type variable. So keep this in mind that the a that I'm dealing with in this case is basically a type variable, and all it means is that the a could be any type. It could be any type. The only constraint is that whatever this type that is associated with my lowercase a must be a number. It must actually be a number. It cannot be anything else. I cannot pass in a string into, or a list of characters into my function f, and I will expect that to get added by 1. A is very, very specific. It must be some type that happens to be a number. Okay, so can I actually show this to you as an example. So if I take my function f and I pass in some kind of a value that happens to be a number. Okay, so I'm making sure that whatever I'm passing in, the type that is associated with my number 3 is actually something that's a number. So one way to check that is if I ask Haskell what's the type for my value 3, I get back that whatever this 3 is basically associated with my lowercase a, but this a is something that actually is a number. And this guarantees that if I were to call f of 3, I'm actually satisfying the constraint for the input parameter to my function f there. So if I say f of 3, I should get back 4. But if I say f of 3, for example, I'm not going to get that out as any. Haskell doesn't even know what to do with this, because I'm violating my constraints as to f is something that can only take in a number. It cannot take in something that happens to be a list of numbers. So so this was like a really quick overview on some of the types, and some of the types that are available in Haskell, and we're going to explore this. We're going to explore this a little bit further in the second part of our video.